All right, it is 9 o'clock. I am, starting the recorder. I always record my lectures as long as I remember how to do it, and I actually get the technology to work. So there are certain days, things do not work out, and it may not be recorded. So that means, if you want to be successful in this class, I encourage you to not fully depend on the lecture recording, but to actually write, down some notes on your own. Okay. Um, all right, so I'm gonna get started. What you see on the screen, my voice and also what you see on the projector are both recorded in the video, and typically they will become available within, I would say, about 15 minutes after the lecture ends. So it is a good way to refer back to the material. But as I said, it is still probably useful to take notes during the class. All right. So we are moving on to kind of go into the actual content of this class. I do have some, kind of general topic that are not specific to this course, such as, how to do your time budgeting and management, how to take notes, how to understand something. Okay, basically, what are the mental processes, in order to fully understand something. Also, how I use GitHub and Markdown as a file format for all the OER content that I create. OER stands for Open Educational Resources. So that means for this class, there's no textbook to buy. Okay, I write all that content, so it is all free. Okay, I see some thumbs up. Now, some people absolutely hate the way that I write because I write in a certain way. Some people find it easy to follow, other people find it really hard to understand. So, starting this semester, I'm creating a GPT TA, teaching assistant, for all of my classes, this one included. So, I'll show you guys what it is and how you can use it. Um, MBTI personality assessment. Okay, it is not scientific. Okay, which means you know, your how MBTI classifies you may or may not be actually who you are, but there's a there are certain clusters of personality types, and also as a result, what each cluster is very good at, or at least they're interested in doing certain things. Okay, so it can be helpful. Okay, in case people are wondering, with all the talk about AI is displacing people in employment, in all the bad news coming from, like Oracle has been firing people just quietly. Many other big tech companies also have been letting go of people, and then all the new startups are going like, oh, we don't need computer science students. We have vibe coding. Everybody can code now. Okay, so as a result, there is a perceived decrease of value of a computer science degree. Okay, now you have to do your own research, okay, to find out what is true and what is not true. Okay, a lot of these things are speculative at best, but at the end of the day, knowing your strengths, your interests, or your aptitudes is helpful to help you make decisions. When you are at a fork, okay, which way should I proceed? Having knowing more about yourself is helpful. So this particular MBTI assessment is free. Okay, so you don't even have to give away your email address. It will give you a conclusion at the end, and if you give it the email address, it'll give you a little bit more information. And then we also have the Bureau of Labor Statistics list of occupations, which will give you some ideas to explore. Okay, if I'm not going straight into software development or software engineering, what are the related fields that I might also want to consider? Maybe it is data science. Maybe it's data modeling. Okay, so there are a lot of occupations that are related to computer science, but it's not straight up, software engineering. So moving past that, we are going to the course information. I will rely on you, each individual, to read the syllabus and make sure that you understand the expectations of, in this class. So I'm not going to get into the syllabus because, that is not a good use of class time. So moving on to shared folder, this is also a useful link for the labs and also many other ways it is actually useful. You can access it already even at this point. You can go ahead, browse around, find out what is over there. Without the context, I really don't think you can make much use of the files already stored in the share folder. It is on Google Drive. These two are not particularly useful for this class because this class is relatively small. I teach this class in the spring by combining two labs, so enrollment can be up to like 60, for my spring class. Now this one is definitely not close to 60 people, so I don't really need to rely on these tools to collect questions in a lecture or for people to ask for help during the lab. This is a prerequisite check, quote unquote, assignment. There's really not much to do. You do want to go in and check that you are receiving 1 out of 1 point, because if you're not getting 1 out of 1 point, that means I cannot verify that you have taken CISP 360 or anything equivalent to that in Los Rios. Now, if you're transferring from a different college, or you are a Sac State student who is taking this class because this class is more impacted at Sac State, then you need to read the instructions so that you can file a prerequisite challenge petition form. Okay, so it's a formal process. Okay, I do need people to have that a verification that at least the petition is filed by the 28th. Okay, so people who are getting no points out of this assignment and do not give me any evidence that the petition process has started will be dropped from this class. All right. I have a YouTube channel. I kind of mentioned that a little bit earlier. So my YouTube channel has all the lecture recording from the past 14 years or so. And I have only taught this class in person, and these recordings are full, like, you know, what, 80 minutes per day. Okay. So there's a lot of stuff, that is already recorded. Obviously, I do not expect you to watch everything. Just watching the video recording from the previous semester, can be helpful because that will give you a preview of what I will be talking about in the next lecture. Now, for this semester, because I'm also recording right now, that means within 15 minutes after the lecture, you will get the recording for this particular lecture. So you don't worry about this particular lecture, but if you want to look ahead a little bit, you can use the past recording so that you can get a little idea of what I will be talking about in the following lectures. All right, and this is the ChatGPT TA teaching assistant. You can ask it, questions related to the class. I'm slowly building up, quote unquote, the knowledge base of the custom GPT. So it does not contain material ahead of time. In other words, it does have all the material that you need for this class, but for the next week, it doesn't quite have those knowledge files yet. Okay, so I have to go through a conversion process from a human readable format to a format that is optimized for custom GPT retrieval. All right, so practice stuff would be kind of the labs from past semester. So after a lab is due, it is no longer available to you. But if you want some additional practice, that's where you can find it. The practice stuff has all the labs so that you can redo the lab over and over again in case you want to gain a better understanding of the content. I'm going to open up this particular quote unquote lab or exercise or quiz. It's not really a quiz. This one is a checklist. It is optional for you to participate. It does not count to your final grade. It is just a way for you to kind of give yourself a self assessment of how ready you are for this class. So it will test you on certain C++ concepts, everything from Boolean operators to pointers to structures. Okay, so you might want to kind of go through that just to make sure that, okay, I think I got these. Okay, if you the score does not matter, it doesn't change your actual score, so it's really more intended as a self-assessment so that you can kind of evaluate where you stand when it comes down to C++ concepts. And this is the module that we are going to start with today. Okay, so today we'll go through the material in this particular, I call this a module. Okay, I used the term module way before we started to use Canvas. So a module is really just notes, or if you will, a free reading material for this class. So all the modules together essentially becomes quote unquote the textbook for this class. Okay, but the modules, are going to be integrated into the custom GPT. So everything in the module in this particular one is already in the GPT um, knowledge base. So if you were to ask, questions related to what we'll be talking about today, the GPT can actually answer those questions. So let me give you an example. I know you guys, this is the first class. I'm not expecting people to have read the module itself, but if we'll be talking about NAND gates, okay? So now I can ask, how is a NAND gate constructed from transistors, which is basically the essence of this particular module, and it will guide you through, based on the content of the module itself. So this is a way, is a resource for you to kind of get a better understanding of the material. I encourage you to give it a try. Okay, you'll see what it can do and whether it will do what you think it should be doing, and give me some feedback if you want to. I also instructed the TA not to give you a straight up answer. So in case of, okay, here's the question, okay, it doesn't give you the straight up answer. Instead, it will evaluate what you need to know in order to answer the question, and then it will check whether you have an understanding of those prerequisite concepts. And if you don't, then it will explain those first. So it's a very gradual process. In other words, in modern day, I hate these fancy words, pedagogy. Okay, so in modern day pedagogy, this is like scaffolding, but it is dynamic. Okay, the system automatically constructs the scaffolding for you depending on how you respond to the GPT's own questions. So anyway, so this is useful, it is helpful, and I am also testing. I'm not sure how helpful it's going to be. So I'm also testing converting the transcript of the lecture recording into knowledge files and upload that to the custom GPT. So in addition to the reading material, it would also have the content of the lectures into in the custom GPT. So I'm not, I'm testing things out right now. Okay, so I'm not really sure how helpful it's going to be, or is it not going to be helpful. But this is an extra resource that some people may find, oh, okay, it's kind of cool. Let me give it a try. Okay, everything said, all your assessments are going to be on paper using a pencil, and no electronics are allowed. So do not become over reliant on ChatGPT. So when you're studying, great, use it, okay? But when you're in an assessment, you cannot use it. You have no access to ChatGPT in the exams. So keep that in mind as well, okay? All right. So with that all said and done, I am going to, start with what you need to do in today's lab. So in today's lab, you are going to use Logisim. There will be instructions in the lab itself to tell you how to download and how to start up Logisim. So I'm just going to go through this to give you a quick idea of how to do it. So I'm using a virtual machine inside the browser because my native operating system is Linux. So the way I use the command line interface is going to be different from Windows, okay? Not by a whole lot, okay? But if you're new to the command line interface, the way I do it may not help you too much. So I'm going to do it inside the virtual machine, which is Windows based. So in Windows, you want to type your CMD on the little search bar here to get to the command line prompt or the command prompt, and then you just click it. And this is the command prompt. You can always Google, Okay, if you want to know how to open up the command prompt or the CMD or the command line interface, they all refer to the same thing. You can always just do a Google search. Okay, you can use Google search, you can use the GPT when you are doing the lab. Okay, there's no restriction when you're doing the lab. So this is called the command line interface, where whatever you want to do, you have to type it. So there are a few really kind of useful commands. One is called dir, which is directory. It will show you the files inside what we call the current working directory. The working directory is exactly what the prompt is telling you. So right now I am on the C drive under the top level subfolder users, and under that I'm under my own employee ID. So this is my current working directory. So from the perspective of the CLI, this is where this is my current location, which means if I need to refer to files that are in other folders, they will all be quote unquote relative to where I am at this point. I just downloaded the file into the downloads folder, but you can see that downloads is a folder, a subfolder of my home folder. So I cannot access the file right away. So if I say dir logisim 310.jar, which is the file that I downloaded, it's not here because it is in a subfolder. So to access things in a subfolder, there are a few ways. You can always specify the name of the subfolder, which is down loads in this case, and then use a backslash to separate components of what we call a file path. Each component of a file path is either a folder or a file. And now I can specify the name of the file, and now it can find it. So this is one way of locating a file. It is called a relative file path. It is relative to the current working directory. So to make things easier for you, I would use this command instead. CD, which is change directory. So this will change your current working directory to wherever you want to go. So by typing CD downloads, I am now changing my working directory to the downloads directory. So this way, I don't need to type downloads as a part of the file path anymore because everything is in this folder. Everything that you download is going to be in this folder. Are we good so far? All right. So I also have a video or instructions, that help you, get around in the command line interface. But for today, it's not going to be too bad. So now I can type, commands like Java as a command, and I type, dash dash version to find out if we have, Java installed. What version is it? So this is the current version installed in this system is OpenJDK, which is actually Java. The version is 21.0.8, and it was last updated on July 17th. Okay, so now that we have gotten to this point, I can now start up Logisim. So to start up Logisim, all this instruction is in the lab already, so you don't have to copy everything down. So this is how I'm going to start up Logisim, which is the program that we'll be using basically for the whole semester. All right, so what you see now in the browser is Logisim itself, and I am going to try to maximize my host browser so we can maximize everything here. Um, and I'm not sure why it is not maximizing. Is it F11 in the browser to maximize? It should be. Hmm, F11. Nope, not doing it. Okay, well, it's fine. We are actually doing okay here. All right. So Logisim, as the name implies, is logic simulator. So it allows you to build logic circuits and then simulate the operation of the circuit. Well, in the context of Logisim, guess what is a computer processor? It is a circuit of logical components. So in theory, we can actually simulate the operation of an entire processor using Logisim. In about week 8 or so, that's exactly what we'll be doing. Okay, I have a processor already designed and it runs in Logisim. Okay, But at this point, we are going to build small components that are in the processor. So in a certain way, this class is a very bottom-up kind of class. We start off with transistors, and then we build NAND gates, and then AND or NOT gates, and then we build adders and subtractors, and then we build register components, and then we build the actual processor. Okay, and then after that, we are going to write assembly language programs for that simulated processor in order to get an understanding of, okay, if I have this function in C++, how does that translate to assembly code? So the idea is by the end of this semester, you will be able to look at a C function, a C++ function. We don't do object-oriented programming here, and be able to understand all the way down to the transistor level of how things happen. So that's the intent of this class, is to give you that kind of like complete full stack of how things get done from the perspective of regular C code. All right. So, but we have to start somewhere. So we're going to start with some simple stuff. Okay. So in the interface of Logisim, this is the toolbar. And the toolbar is really limited. So I'll go ahead and explain things as we go along. This part of the toolbar has all the commonly used components. So I would use this. Okay. So to add a pin to a circuit, which is on this side, all you have to do is to click on the component that you want to add, and then click on this part of the screen to create the component. If you have already taken object-oriented programming, these are the classes. Okay, and there are some additional classes down here, but we'll just talk about these first. So these are the classes. This is your program code. So by clicking on the class, you're saying, oh, I want to make an object of that class. I want to instantiate a variable of that type. So when you, this is not a drag, by the way, it is just your point, move the mouse and click. So when you click on this screen here, you're basically saying, okay, since I have selected this class, this is an object of that class. So I can now do the same thing with the output pin. So this is an input pin. This is an output pin. The input pin is a square. The output pin is a circle. And these are quote unquote equivalent to pins on the circuit board. I'm not sure how many of you have played with a Raspberry Pi or an Arduino. How many people have at least some idea of what those things are? Okay, we have some number of people. So basically, those are what we call single board computers, and they have these headers with pins. So with those pins, you can attach, sensors, you can attach LEDs and other things to it. So basically, a pin is an interface for a circuit to talk to something else. In programming, we have kind of similar concepts. An input pin is analogous to parameters to a function, and then an output pin is analogous to return values of a function. Are we good with those concepts? Okay. And if I'm talking too fast, let me know. Okay, if you want to take some notes and you're trying to keep up with the way I talk, and you need a little bit more time, just raise your hand. Let me know that you need more time. It's not a problem. Okay, because I do want to make sure that people have enough time to take notes. Yes, it will be in the lab instructions. So try not to do exactly what I do, but follow how I do it. Is that okay? Okay. The lab instructions will tell you how to do it. Okay, so focus on the concepts, focus on what I'm talking about now, and not so much exactly how to do it. Okay. All right. So parameters and return values. Okay. So if I want to make a tiny little circuit here, I can do that. It's not going to be a very useful circuit because it just returns exactly the value of the parameter. So the way you create a circuit is with every component, okay, this is a component, there are at least one, okay, one or more, what we call ports, okay? So the type is an input pin, but this little thing here is called a port. So the idea is you want to connect from a port to another port like this. Now, if you don't do it this way, okay, and you say, oh, I want to use the top here to connect to this thing here, well, you can draw it like that, okay, okay, maybe not even that, but you can actually draw something like this. Oh, nope, it won't even let you do it. So the key is to remember that you have to end with the port of a device. I think I can demonstrate it in a slightly different way. So let's say you want to connect to the input pin, but on the top. Okay, so I can draw the wire like this. It looks like I have a connection, but in reality, there's no connection because the location of the connector is here. This is not a connector. So even though it looks like the wire is contacting the component that you want to connect to, there's no logical connection recorded by Logic. Does everybody understand what I'm saying? Okay. All right. So fixing this problem here, I can just kind of drag this line to exactly where the port is. So now I have a circuit. The output pin is now just reflecting whatever the input pin has. So now I can try it out. Instead of using the pointer tool, I can now change to what I call the poking tool. So the poking tool, I call it the poking tool because it has a finger. So whenever you click on something, you're poking something. So the poking tool allows you to change the value of an input pin. So I can now change the input pin to a 1, and then the output pin reflects the state of the input pin because it's directly connected. So not a very useful circuit, but nonetheless a circuit that illustrates a few points. Do we have any questions about this particular circuit? All right. So without any questions about this, we're going to add some more components to the circuit. So I'm going to get rid of, well, let's see. Yeah, I'm going to get rid of this connection here and focus on an input pin. Whatever component you have selected in the circuit, this portion of the screen will show you the properties of that particular thing. So you can look at this part of the window as a view into the attributes of an object. Is that okay? So these are the properties related to the thing that is being selected. So we'll go over these kind of step by step. For an input pin, phasing has to do with where is the connection point. At this point, it is to the east, but you can see that you can make that point to be to the west, to the north, or to the south of the pin. In other words, you can kind of rotate the connection point around the square just for display purposes. Some of these options may be more uh, aesthetic. So it's just for the looks. Since this is an input pin, it is not output, so there's a no here. Data bits is important. So when you look at this, this is a single conductor on a pin. In other words, you can only hook up one thing that can either be a 1 or a 0 to this input pin at this point. But you can change the data bits from 1, let's say, to 4. So now I have a 4-bit input pin. It is one single quote unquote input pin, but it has 4 individual bits. One bit is a binary digit in it. Is that okay? And each digit is independent from the other digits. So if I were to use a poking tool, I can go like, oh, I want to toggle this bit from a 0 to a 1 and toggle this one back from 1 back to a 0. So that's how you can change the state of a multi-bit input pin. Are we doing okay so far? All right. So let's just say that, I want to change the output pin to 2-bit. So here I change it to a 2-bit output pin. So now I have a problem. Okay, let's just say that I want to make a connection between the input pin to the output pin. We naturally end up with a problem because there are 4 input bits. There are only 2 output bits. So now the question is, how do we specify the output bits? Because how do we calculate it? So let's just say that what I really want to do is for bit 0, which is this particular bit here, to go to bit 1 over here. And I want bit 3, which is this bit over here, to go to bit 0 over here. Okay, so for this, it might be helpful to kind of give the pins names. So we'll go ahead and assign names. To assign names to the pins, all you have to do is to go to the label property of the pin. And I'm just going to call this one in, and I will call this one out. Okay. And I would use a text tool here to document what I really want to do. So what I really want to do is for out 0, bit 0 of the out pin to be the same as bit 3 of the input pin. And I also want out 1, which is bit 1, the one to the left, to be the same as in 0. This is what I want to accomplish. Do we have any questions about this notation here? I'm borrowing the array indexing operator from Cisp 360 to designate which bit within a pin do I want to specify. Is that part okay? All right. So how do we do that? Well, we need to use a splitter. So now we have to kind of delete this wire because a direct wire is not going to do the trick. So get rid of this wire. We need 2 splitters to be exact in this case. So now you go to wiring. Okay, so now we have to get to use the more we have to expand the hierarchy of tools that we have. So you can see there's a construct called a splitter here. So we're gonna put a splitter into the circuit, and now we can take a look at all the properties of a splitter. It has a phasing, which basically is okay. First of all, a splitter has 2 ends. There's one end here, and there's an end over here. So the left-hand side right now of the splitter is what I would call the merged end, okay? And then the other end is going to be the split end. Okay, that's just how I refer to it. The built-in help has a slightly different terminology, but I will show you how to do that too. So the merged end is there's only one single merged end. So it goes to a wire that internally has multiple bits. The split end, each one of the split end can take at the most, okay, I shouldn't say that. It can take certain bits out of the merged end to present to the merged end. Okay, so because this input pin is a 4-bit input pin, the merged end of this splitter, which is intended to connect here, has to be 4-bit as well. So let me just make that connection so that Logisim will complain about it first, and then we'll fix it. So we have to connect this wire to this point here, and you can see how Logisim is not happy about this situation because the splitter only has 2 data bits, and I'm trying to connect 2 data bits to the input pin, which has 4 data bits. So in this case, I'm not changing the input pin because I really want the input pin to have 4 bits. So the only thing I can change to reconcile the bit width is to change the splitter from 2 data bits to 4 data bits. Is that okay? All right. So now I have the freedom to say, okay, so which one of the bits of the merged end goes to which end of the split end? I have control over that. So the way I can control over that is to use these 4 things down here. So this is bit 0 from the merged end. Does it go to the top split end, or does it go to the bottom of the split end? You can also control the fan out ratio. So if you need 3 of them, you can turn to 3, or you can even turn it down to 1, which means you are selecting only one of the 4 bits of the merge end to become the only output of the split end of the splitter. Are we getting an understanding of what a splitter is and what purpose it serves? Okay. In other words, you have a bundle of wires as a single thing coming in. You can go like, okay, I need to rearrange, okay, these wires, to the output. The output is going to be like multiple wires, and those wires will take, whatever is in the input wire. Okay. All right. So in this case, I have no use of bit 1. I have no use of bit 2. So those 2 bits of the input of the merged end of the splitter will be going to none of the split end. So right now, you can also see from the numbering here that bit 0 of the input is going to the top split end, and then bit 3 is going to the bottom of the split end. Are we good so far? So I can test the circuit now to see whether it is actually doing that. Yep. So bit 0, which is the rightmost digit of the input pin, is going to the top split end of the splitter. Bit 3, which is the leftmost bit of the input pin, is going to the bottom split end of the splitter. Sure. But I can test it. The way I can test it is to change to the poke tool again. And this time, I'm just going to poke bit 0. And you can see how, when I change bit 0 to a 1, this top split end becomes light green. In other words, in light green means a 1, dark green means a 0. So this is a really quick way for you to check a circuit. If the bits, if the wires are only zeros and ones, you can visually see the value without having to hook it up to an output pin because the color tells you the value that is currently on a wire. Are we doing okay with that concept? Okay. So likewise, I also want to make sure bit 3 is going to the bottom of the top of the split end. So I can now toggle this bit. Okay. So the circuit is working the way that I want it. So, but now the question is, but how do we get this into the out pin here? Because each one of the split end only has one single bit. So that means if I were to just go like, oh, maybe we'll just kind of connect it like this to here, it's not going to work because this split end of the splitter is only 1 bit wide. This is 2 bit wide. So that means we still have a problem with bit width. So this approach does not work. What we need is another splitter. So we'll take another splitter here. But this time, the merge end is going to connect to this point here. So this doesn't look good. So what I want to do is to make it face west. So this way, the merge end is pointing to west, and it just looks better this way, like so. Is that okay? All right. So now there's only one thing else, left for me to do, which is, we need bit 3 of the input pin, which is this split end here, to connect to bit 0 of the output. So these two need to be connected. Okay, that's pretty easy to do. Mm, Okay. I don't have a mouse, and my keyboard, the mouse button is a little bit finicky. There we go. All right, cool. So let me check again because this bit here is supposed to connect to this bit over here. So I just want to go toggle it just to make sure that it is working. Aha, it's working good. So now this particular split end will have to connect to this particular split end. So change back to the pointing tool. And I now have a crossover. Okay, so this wire is crossing over the other wire, which means they are not connected. So now I have done the circuit. In other words, if I were to toggle bit 0 of the input, then bit 1 of the output is going to toggle. If I were to toggle bit 3 of the input, then bit 0 of the output is going to toggle. And this particular junction here is called a flyover, which means it is kind of like having two highways. One is an overpass of the other one, so there are no collision. Is that okay? All right. So let's just say that you have not been taking notes and you have been going on Amazon to shop for something that you have been longing after for a while, and you totally do not understand what a splitter is by the time you do your lab. What are you going to do? Well, you can review the lecture, but there's even a better resource. You go to help, you go to library reference, and then you go to wiring library because the library documentation has exactly the same structure as this hierarchy of tools here. Then you go to splitter and you can read all about it. Are we good so far? So that's one way to do it. And then there's another way to do it. You can also ask the TA. The TA, in other words, I have imported the individual help files into the TA already. So now you can go to the TA, the GPT TA, and then you just ask, okay, how do I use a splitter in Logisim? And it will tell you. Is that okay? So I am thinking, now I can be wrong, obviously. I'm thinking it should be impossible to fail this class. I think people really have to try, like put in a lot of effort to fail this class with all this, additional resources, to help. So it actually tells you everything you need to know. Now it doesn't show you diagrams, okay, not like the other one, which shows you the diagram, but it does give you the verbal instructions of how to use a splitter. Is that okay? All right. So these are all resources that you can use. All right. So now that we are done with this part, I'm going to change the circuit a little bit, and we'll get to the actual content that we need to go through in today's class. But before we get to make the entire circuit, I'm going to have to explain what is power and also what is ground. Okay, I'm just aligning the thing. There we go. Okay, do you notice the color of power and the color of ground? What are they respectively? Power is light green, right? And ground is dark green. That's right. And both of those only have one single port, which means this is the port corresponding to power. This is the port corresponding to the ground. So essentially, power is an endless supply of ones, and ground is an endless supply of zeros. That's right. Okay. So that's how you can look at these two. Okay. Power is an endless source of ones, which is positive charge, and the ground is an endless supply of zeros, which are negative charge. Okay. So now, with that in mind, we can now go like, oh, I want to test this tag. If I were to hook up a input pin to power, the input pin should become a 1. Yes. If I were to hook up the output pin to ground, then it should get a 0. Yep. Okay. So you can also, you can always design experiments to help you gain a better understanding of Logisim and the components in Logisim. I encourage you guys to do it as a part of how you study for this class. Remind me again, what does it mean when we say, oh, this is a 1 unit class or this is a 3 unit class? What does it mean when you're taking a 3 unit class? What is it and what does it mean? So let's say the class is all lecture. So it's a full just lecture class, but it's a 3 unit class. What does it mean? First of all, what does it mean when it comes to lecture time? You actually have to spend that time. If this is like an in-person class, this is the amount of time you have to spend in the classroom. So with a 3 unit class, how many hours do you have to spend in the classroom itself? Well, it does. Does it have a lab component to it? Yeah, it's quote unquote 3 hours, but it's not because it's 3 hours per week when we were on the 18-week schedule. But since we are now on the 16-week schedule, it's a little bit more than 3 hours. But the bottom line is it's 54 hours for the entire semester. Okay, so for a 3 unit class, all lecture in person, you are spending basically 54 hours in the classroom. Okay, but there's more to it. Okay, because each unit is also assuming that you spend 2 extra hours outside of the classroom to study, to review the material, to revise your notes, to do your homework, to prepare for exams, 2 extra hours for each hour in the classroom. So that means for a 3 unit class, you are spending 54 hours physically in the classroom, but you're also expected to spend 108 hours over the semester to study, do your homework, revise your notes, make your own study guide, and so on. Okay? I want to make this clear because in order to succeed in this class, an average student will need those 108 hours. So you have to budget for that time. Okay. And that's why earlier I showed you a little slide that says, okay, how do you budget your time? Well, you have nothing to budget unless you already have, take it back, sorry. How do you manage your time? There's no time to manage if you did not budget for it to begin with. Okay. So that's why, at the beginning of the semester, it's too late kind of now. I always try to tell people don't enroll in too many classes because if you enroll in too many classes, you are not having a reasonable budget. Then it doesn't matter how you manage your time, you just don't have enough time to begin with. You had a question? Yeah. Oh, I thought you had. Okay, go ahead. Aha. So very good. So blue in this, before we proceed to explain blue, do we have any additional questions about what a unit means, when it comes down to the number of units for a class? No. Did you know that before I mention it? Some people do. Okay, so if you did not know it before, now you know. Okay, this is a very important piece of information, especially after your transfer. So a blue, okay, if I were to extend the Y, is blue too. So that's a very good question. A blue means this wire and also this output pin is not connected to anything. It is what we call floating. In electrical engineering, it's called floating. It's basically saying a conductor is just sitting on the motherboard or on the circuit board. It is not connected to a one, it's not connected to a zero. It's just like dangling and doing nothing. Is that okay? You cannot treat it as a zero because, so if you look at a wire on a circuit board, or if you just get a wire and just let it free flow, it's actually picking up electromagnetic radiation. So the voltage that you measure at a point can actually change depending on whether somebody is running a microwave next to you or whether the phone is ringing next to you, because those are all RF intensive devices, and RF can induce electrical potential on a conductor because of inductance. So, not getting too much into electrical engineering, a blue wire is not a zero. It's neither a zero nor a one. It is more like an unknown. We don't know what it is. Mhm. Yep, neither do I. Yeah. So in the real world with the processor, they're all DC devices. They're all direct current devices. And the actual voltage is not important from our perspective because our perspective is basically is it a zero or a one? We don't care about the values in between. So in this class, VCC or power is just one, and then ground is just zero. Yep. So we are taking a more logical perspective to circuit design. We are ignoring the actual physics for the most part. All right. So now that we have power and ground, we can now talk about transistors. Okay. So a transistor is in here. Okay. This is a transistor. So let's go ahead and take a closer look at a transistor. All right, so this is a closer look at the transistor. It has three ports, okay? Unfortunately, in the case of a transistor, the ports are not labeled, so I have to kind of mention these by name, and you might want to jot down some notes if you want to. You can also use, the library to help you because I think that actually tells you the labeling of the ports. Not directly in the picture, unfortunately. Well, actually it does. Okay, so it tells you this is the gate. This is the no, it doesn't label the ports. So I'll do it. I would do it. All right. So the top one, which is easy to identify, this is called the gate. So I'm going to use G as an abbreviation of the gate. This one here is called, okay, I'm not going to say this one. I will say that of the remaining two ports, one is called the source, the other one is called drain. So can you guess which one is source and which one is drain? Just left hand versus right hand. Yes, that is correct. So what gave it away? The arrow. That's it. Okay, very good. So the arrow is indicating flow. When the gate specifies, oh, this valve is open, you can have stuff flowing in it. It is flowing from source to drain. So that means the left hand port is the source, the right hand port is the drain in this case. Okay, so this is source and this is drain. Okay, and if you take a look at okay, let me go back to the selection tool. This transistor is also known as a p-type transistor, and the other one is called an n-type transistor. But we'll focus on the p-type transistor first, and then we'll move on to talk about the n-type transistor. So with p-type transistor, it doesn't really have much else to talk about because once we already know what it's facing, it just kind of helps to rotate the part, and the gate location can flip from one side to the other side just so that the circuit looks nicer, okay? And then the number of data bits is going to be one because we want to build simple circuits, so it's always going to be one. So now the question is, what is the behavior of an p-type transistor? The input to the transistor, so to speak, is the gate. In other words, the gate is the control, and it controls whether you allow stuff to flow from source to drain. Is that okay? In other words, a transistor is a valve. Okay, it's kind of like a faucet, or if you will, a switch. Okay, but the bigger question is, what stuff is flowing from source to drain? In the case of a p-type transistor, it is positive charge that is flowing from source to drain. So between power and ground, which one do you think will give you positive charge? Power. That's right. Okay. And now the next question is, so when does it allow stuff to flow through and when does it not allow stuff to flow through? So I'm going to write those rules down here because this is actually kind of important and we want it to be aligned left. There we go. So with a p-type transistor, flow is allowed when the gate is less than the source. So when the gate has a charge that is less than the charge of the source, then it is on and it will let positive charge to go from the source to the drain. Okay, it sounds a lot worse than it really is. Okay, so what we'll do is we are going to build a tiny little circuit here to illustrate this point. So I'm going to pick a transistor here, rotate it to point south, like this. Use an input pin to connect to the gate, like so. And I'm going to turn off simulation first, just so that we cannot immediately see the result, because I want to ask you guys to think about what is the result here and make a connection here. Okay, so in this tiny little test circuit, power is the infinite source of ones, which is also known as positive charge. The source of the transistor is connected to the endless supply of positive charge. The gate is connected to a pin so that I can control the voltage or the charge of the gate. So now the question is, what is at the drain at this point? What should it be at the drain at this point? I'll give you three possible answers, okay, of which only one is correct. Is the drain also positive, being a 1? Is the drain negative, being a 0? Or is the drain floating, meaning it is blue? Under the current configuration, the only information you need is this. So the question is the gate less than source? Yes. So it is allowing flow, and what is flowing through is positive charge. So that means positive charge is now flowing through the valve and arrive at the drain. So when the drain has positive charge, it is 1. Is that okay? So now we'll go ahead and let the simulation to tell us whether that is correct or not. So you go back to simulate or type Control E to re-enable the simulation. Aha, we got it. Is that okay? All right. So what about the opposite situation? So I type Control E again to disable simulation and reset simulation so that we don't have the colors to confuse us. So now we change the gate to a 1. So what do you think is going to happen in this case? What do you think is going to be the color at the drain? Now, since we know it's not going to be bright green, it would be useless for a transistor if it is also bright green. So the question is it dark green or is it going to be blue? All right, it's going to be blue. It's going to be blue because at this point, the transistor is off, simply meaning that there is no path from the drain going back to the source, but it is also not connected to anything that is negative or to 0. Are we doing okay so far? Of why the drain is blue instead of dark green? The absence of charge makes it blue. The presence of positive charge makes it bright green. The presence of negative charge makes it dark green. Out of this entire circuit here, there's no source of negative charge. It cannot possibly be negative. We good so far? All right. So now we can move on to the other transistor type. So I am going to do whatever is minimum to get it changed. So I look at this p-type transistor and turn it into an n-type transistor. So focus very carefully on the screen because I want to ask you, so what is the difference between an n-type and a p-type transistor just from the appearance? So look at the p-type transistor carefully, and now we switch it to an n-type. There we go. What is the difference? Mm, but we are looking at the diagram. The little bubble is missing here. That's the only visual difference between a p-type versus an n-type. The p-type has a little bubble at the gate. The n-type does not have the bubble at the gate. Is that okay? The rules of, so an n-type transistor is also just a valve, which means it is just controlling flow. So now I'm going to do the next thing that is really lazy, which is copy and paste. Uh, Control C, Control V, there we go. And now I just have to change a few things here. For N-type transistor, just about everything is opposite. Flow is allowed when gate is greater than source. You're like, oh, okay, that's pretty easy to understand. But there's one extra thing that is different. Because with an N-type transistor, the source has to be in a supply of negative charge, and then the drain is just saying, okay, am I connected to the source? So that means the source of an N-type transistor should connect to negative charge. All right, so we'll go ahead and modify the circuit a little bit here, just so that we can change the design to an N-type transistor. So now we switch this to an N-type, and I'm going to flip the direction. So facing is going to be north. So, and then we have a ground. Oh, actually the ground is already here. I'm just going to use the ground that is already here. And then turn off simulation and reset. All right. So because the source of an N-type transistor has to connect to a source to where the negative charge is, so that's why the source connects to ground in this case. And the gate has a 0 here. So the first question is, are we allowing flow through the transistor, through this N-type transistor at this point? Is the gate greater than the source? Nope, they're both zeros. So that means it is not connected. So what do you think should be the color of the drain, which is here? The valve is completely shut off. Whatever is presented at the source does not connect to the drain. So what should be the color of the drain as the circuit shows at this point? It should be blue. Yep, because nothing connects to the drain. So we'll go ahead and re-enable simulation, and sure enough, it is blue. Okay, cool. So now we turn off simulation and reset. And let's say we flip the input pin so that the gate is now a 1. So when the gate is a 1 and the source is still a 0, 1 is greater than 0 is true. So when gate is greater than source, in the case of an N-type transistor, flow is allowed. What is coming from the source? Negative charge, zeros. So now the negative charge is connecting through the transistor to the drain. So now the drain is also getting the negative charge, otherwise known as 0. So in this case, the drain is going to be dark green, like that. Are we kind of doing okay so far with this circuit? All right. So now the question is, so can I build a circuit like this, if I'm curious about the operation of this particular circuit? The answer is yes. It's actually pretty easy. You go to AutoZone or any auto supply stores, and you get some of those 12-volt relays. Everything that a transistor can do, a relay can do too, except a relay is a lot slower. Okay, it makes strange clicking sounds. But you can actually build the same kind of circuit that we are talking about today using relays. They are not terribly expensive. You can order those from, not Harbor Freight, Amazon. Yes, you can just kind of, yeah, you can hook up the wires. It's better to solder or use a breadboard to kind of connect the components. Yep. But you can build a circuit like this. So now that we have understood, the basic concepts of, all of these components, we're going to make the circuit. Okay, we're going to make a circuit that is kind of useful. And I use kind of because it really is just kind of. Okay, so get rid of this stuff, get rid of this, and I'm going to get rid of this too. There we go. And you can always select an area, and then everything inside the area can be deleted all at once. So now I'll build a circuit out of transistors. So we're going to need 2 of these. And if you select multiple items, okay, I don't actually need the other part either. Let me zoom out. So zoom control is here at the bottom on the left-hand side. So you can control the zoom level, using that control. So I'm just going to select this whole thing, get rid of it, select both of these p-type transistors because I want to rotate both at the same time so that they both face south like that. But with this one only, I want to flip the direction of the gate position. So this one flips to the other direction. And then just going to move these both to right here. There we go. And now I need two N-type transistors. So I can also use a trick like this. Control D duplicates. In other words, it is combining copy Control C and Control V into one single step. So now I need to move this down a little bit here to make room. And I need both of these to convert to N-type transistors. So I can now select both. And because they're both of p-type at this point, I can now convert both to n-type at the same time. And I also want both of these to face north, like so. And now I can connect the rest of the circuit together. Yeah, that would do. Okay, maybe move this one. Ah, there you go. And then flip this one to the other side. That's just to make it look nice. And then we have two input pins and one single output pin. Alrighty. Output pin goes here. All right, so now I'm making actual connections, connecting components of the circuit. So I'm going to turn off simulation because I want you guys to be able to analyze the circuit and tell me what is happening to the output pin when I tell you specific things about the input pin. And we can zoom out one more level. There we go. There we go. And this one also connects to one of the N-type down here. Uh, Ugly but functional. All right, and this one also connects. Okay, I'm gonna need a two-hand operation here. This hooks up here, and this one hooks up here. There we go. Okay, so this is now a functional circuit, and let me just reset the colors so that we do not get any colors on the screen. Reset simulation. There we go. So can someone tell me what the output should be at this point? Should it be a 1 or should it be a 0? Or do you think it's going to be an X or blue? So how do you answer that question? You start with the output pin, you go to this junction here, and then you ask, am I could be connected to power, which is the source of all the ones? Okay, so that's the question that you need to ask. So that means I'm really asking, is this particular p-type transistor on and allowing flow, or is it off? What do you think? It is on because the source is greater than the drain, or the drain, I mean, so the source is greater than the gate, or the gate is less than the source, so it's on. So if the transistor is on, that means it is giving me a path from this junction all the way to this point over here. So that alone tells me that the output pin should be a 1. But let's finish the analysis. So we go all the way here, and then we ask, oh, is this transistor on or not? The answer is yes, it is also on because the gate is also a 0. So that means I have two paths from the output pin to the power. What about ground? Well, I don't have any path to the ground because this is an N-type transistor. With an N-type transistor, this is the source and this is the gate. Is the gate greater than the source? They're both zeros. So that means this transistor is off, which means I do not have any path from the output pin to the ground. So it has no exposure to negative charge or zeros. So when I re-enable simulation, you can see the output is a 1. All right. So if you're not quite following all the steps, it's okay, because this is the first time you are exposed to the concept of a transistor. But if you listen to the lecture again or review your notes, hopefully you're taking notes, you probably should be able to follow the reasoning of why the output is a 1. Yep. So what do you mean by the bottom is 0? Yes. No, that's not what it says. Okay, let me turn off simulation again and reset to simulation. There we go. So the poking tool, there's another use of the poking tool, which is you can poke a particular wire. It will highlight everything that it connects to. So you're talking about this pin, right? So you can see how this pin or the bottom pin is connected to the gate of the bottom N transistor, but it also connects to the gate of the right-hand side P transistor. Is that okay? So the pin itself is only influencing the gate voltage of both of these transistors. It is not directly related to what is in the circuit. It's only controlling the valves. The valves are the ones controlling the connectivity between the output pin and the sources, either the 1 or the 0. Yep. All right. So now the question is, what if I want the output to be a 1? So I'm reversing the questionnaire. Instead of telling you, oh, these are the inputs, what is the output? I'm reversing the question and say, I want the output to be a 1. What input will, no, I take it back. I want the output to be a 0. What needs to be the input in order for the output to become a 0? So let's go through the reasoning. Okay, so I'm not only giving you the answer, I'm also trying to illustrate how to reason this out based on what we have already learned. Okay, so let's see. We want the output to be 0, which means I need the output to connect to. So I'll give you four choices. Okay, if I want the output to be a 0, I need the output to connect to this input pin, power, or ground. Ground. Very good. Okay, so I am really looking at, hey, I need to find this path here. Okay, I need to find a path to go from here through this transistor to here, through that transistor to here. That is what I'm looking for. Is that okay? But that path has two gates, okay? It has two valves. This is one valve, this is the other valve. Both valves need to be open, allowing flow in order for ground to eventually connect to the output pin. Is that okay? So now the question is, how do I open those two valves? Okay, so we look at those two valves and say, what kind of valve are we talking about here? This is an N-type transistor. So now we So now you're supposed to look up your notes and say, okay, if it's an N-type transistor, to turn it on, I need, okay, what is the relationship again between the source and the gate? The gate needs to be greater than the source. Okay, very good. So the source is always going to be 0 here, right? So that means the gate has to be a 1. which also means this input pin has to be a 1. Well, that will present ground all the way up to here because this valve is allowing flow. But there's another valve here that is stopping the flow from the ground to this pin here unless I turn it on, right? So what type is the other transistor? It is also an N type. This is also an N-type transistor. So now you ask the same question, which means, oh, how do I turn this valve on? How do I allow flow with this valve? Oh, the gate has to be greater than the source. Well, the source is already a 0 because we turned this one on already. So there's a 0 at the source of this transistor. That means I need this gate to be a 1 as well. That 1 goes to this input pin. I need both input pins to be 1s in order for the output to be a 0. So are you guys following the reasoning, the chain of reasoning? So this line of reasoning is really step by step. I look at the circuitry and I say, okay, in order to accomplish the objective, I need these two valves to open. Then I look at each valve and I ask, how do I open this valve? Okay, blah, blah, blah. Okay, make that input pin a 1. Okay, now I have ground presented to the input or the source of the other valve. How do I turn on that valve too? Same answer. So that is the chain of reasoning to solve that particular problem. Okay, so from time to time, I will bore this class with an explanation of what goes through my mind to solve a problem. Because I think the knowledge of this class is kind of useful, but it's not the most useful thing. Okay, the most useful thing is for you guys to develop that problem solving critical thinking skill because programming languages will change. The AI tool will be able to do the low level stuff. It can even create programs. So what is your job? In the age of GPTs being able to create programs in just about any programming language, what is your job as a software engineer? Yep, to make sure that code is correct, which means you first need to be able to come up with the code in the first place. Now, it might take you a week to do something that GPT can do in 5 seconds, but the outcome of the 5 seconds is unchecked. We don't know whether it works or not until you go in as a software engineer, knowing what you're doing, go through that program and say, yep, I can verify the code makes sense. Now, you did not invent the code, you did not come up with the code, but you are capable of analyzing that code to make sure that it is all good. That is going to be your job skill. You may not be coming up with the program, but you're going to do something that's even harder than coming up with the program in the first place because you're going to have to review the code generated by something else. Okay, so I just want to keep that in your context, okay? Because most people say, a lot of people say, because of vibe coding, there's no need for people to understand programming anymore. I would strongly disagree, and some of you will probably see I would give it at the most 1 year of these startup using vibe coding. Some of those will fold in a terrible way because the code that is generated is not secure. It doesn't scale and has many other problems that the vibe coder did not anticipate because of the lack of understanding of computer science. Okay. Yes, my lectures are recorded. If nothing happens within a year, you can always come back to me and say, Tech, nothing happened. Vibe coding is all cool. We don't need a computer science degree anymore. Then what are you guys going to do? All right. So I think that pretty much concludes what I need to disclose in the lecture. So what I will do now is to release the lab because the lab is invisible to you. And so this is what we call the lab. It is in the form of a quiz in Canvas. But it really is not a quiz because you have all the time until 11:50 a.m. to complete the whole thing. and you have an infinite number of attempts as well. So that means, oh, you try once and you got a not so good score, do it again. Okay. Many of the questions are multiple choice, which also means people who want to use what I would call the infinite monkey approach can do so. But then those people have to question and ask, is this helping me understand the material? Because at the end of the day, that is the thing that matters the most. Okay. But you do have opportunities to redo or reattempt. Okay. You can refer to ChatGPT and ask questions and use it as a resource. Okay. Because the whole idea of the lab is for you to utilize what you have learned in the lecture to try to solve a problem so you get some hands-on experience. And in the process, if you have any questions, you want to get those questions addressed. So you can ask me, you can raise your hand, I will come to you and answer your question. You can use ChatGPT. You can refer to the lecture recording from Monday, yesterday, because it is for the most part the same lecture. So you have all of these resources available to you. And also, hopefully, you also took notes along in the past hour or so. And so you can refer back to your own notes. Are we good so far? All right. So you will need to know the access code to the quiz. The access code to the quiz is Logisim itself, all in lowercase. I will put it on the whiteboard. It's just logisim, all in lowercase. That's your access code. At the end of the lab, you will need to turn in the file, and the interface to turn in the file is quote unquote the companion activity. And I have to change the date because it is not updated from the other class. So I'm going to have to change that to today at 11:50 a.m. So with that, you should be able to get started. If you're having problem getting into the lab, let me know because I might have screwed up something. Oh, by the way, you're also allowed and encouraged to use Google search. So, if you want to figure out, oh, how do I do this command line stuff, blah, 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 you can also do a Google search. You can watch YouTube, in the class during the lab. You can collaborate to a certain extent with other students too. Just don't try to copy just the answer. Okay. But if you guys want to talk about the topics and how to approach the answering of a question, you can do that during the lab as well. All right. So I think everything is in place. I will go back to my office. I'll get some water to drink, and then I'll come back here. You guys can go to the bathroom if you want to. Take a break before you get started with the lab, or just get it started right away, so you can get an earlier lunch. It's up to you. I'm gonna stop my recording and upload it to YouTube.